So we have our next speaker coming up, Nicolas Frankel, a developer advocate, Hazelcast. At this point, he's a software developer and architect with 15 years experience in demanding environments, while he works with a wide range of customers and contacts in telco, banking, insurance, large retail public sectors, focused on Java and Spring technologies. He's a part-time lecturer and he's curious about pragmatic stuffs. And he's a author of the book Vaadin Integration Testing as well. With that, a warm welcome to Nicolas Frankel.
Thank you. Thanks a lot. I guess you see me. And I can start.
Yes, Nicolas, we can see your slides. Hello.
How to move your app, your legacy app to the cloud. I'm very happy to be here. This is my third time in a row at the OSCONF conference, so I'm very humbled by that. Well, you introduced me. After having been in the tech field, now I'm a developer advocate. So now I can do like crazy stuff that have no schedule. That's pretty cool. I work for a company called Hazelcast. Hazelcast has two products. The first is called IMDG, in-memory data grid, and basically you can think about an in-memory data grid as data structure that can be distributed over the network. So instead of being limited to the memory of one node, then you can scale horizontally, and you still have the same interface as your traditional data structures, just as dictionary or whatever. And our second product is called Hazelcast Jet, and basically it allows to do in-memory processing of streams. So have a check. This talk is about the cloud gold rush. I mean, right now, everybody wants to move to the cloud. If you are not on the cloud, you're a legacy organization. Nobody wants to work for you. And you will be like left alone while everybody is happily moving to the cloud, because of course the cloud will solve all your problems. And there are basically two reasons beside the hype to go to the cloud is cost management and flexibility. So basically you pay for what you use. So if you use not much, you don't pay much. If you use a lot, you pay a lot. That's fine. And flexibility is actually the fact that, let's say, take an example of the e-commerce shop. Basically, all the year you've got like an average load, and then on Black Friday and Cyber Monday, then your load is much, much higher, let's say 3 times or 4 times. And then if you are not on the cloud, if you have your own infrastructure, that means you need to size your infrastructure for these peak loads. And the rest of the year, this stuff just sits there for nothing. And the story goes that it was how Amazon Web Services started, is basically because, well, the rest of the year, there are all this infrastructure that was not used, and they decided, hey, let's make use of it. So let's propose it to other people. And it's very important to remember that you don't go to the clouds to be like everybody, to be hype or whatever. Is just to manage your cost and to be flexible. And I'm afraid that in some places you move to the cloud because everybody does, and then you notice that it's more expensive and you don't use the flexibility and in three ways to move your app to the cloud. So suppose you have a legacy app and you say, okay, I will take this legacy app, I will just, let's say, wrap it under a Docker container and move it to Kubernetes, and it's done. And it's known as lift and shift. You don't care that much, you just be very, very fast. The second is to rewrite your application and to make it like cloud native. whatever that means. And perhaps, and I hope that in this talk, I will try to show you there is a middle path. So lift and shift is very easy. You are just viewing the cloud as somebody else. You run your application right now on your own infrastructure, and you decide, hey, I will move it to another infrastructure. And as I mentioned, it's relatively easy. You just like read a bit about Docker, read a bit about Kubernetes. You make your application Docker friendly. You hack your YAML, and then you say, hey, run it. The problem with that approach is basically you are ignoring a lot. And in some cases, it might be much more expensive than on-premise. Because of course, let's say I will be using the GVM as an example because I'm a Java developer. The GVM like uses a lot of memory, as long startup time. So basically, if you are using Kubernetes and having your application, your GVM application in containers, and it's not responding, then Kubernetes will kill the node. It will start, will kill the pod, will start a new pod, which takes a long time regarding like in the cloud considering. And then the memory will be much higher, and it's going at least to cost a lot. And if you forget about logging and a lot of different things that for you were granted on your infrastructure, or how you debug stuff on the cloud, then it will be really a mess. There is this things called, I mean, it's already quite old, called the 12-factor apps. And I guess that most of you are familiar with it. And there are like those 12 rules that make an app cloud ready. So for example, you must have one code base. You just don't have different code bases for the different environments. I mean, the app must be self-contained and so on and so forth. I wrote everything here for your own consumption. It's no use that I read it again to you. Again, I guess that you must be familiar with that. And if we take a Java application, a GVM web application, we can already see that some of their rules they are not like, for example, if I have a war, a GVM web application generally is a war artifact that is deployed to an application server or a Tomcat. Well, that means that you have a Tomcat running, you take your war, you deploy it to your Tomcat, meaning that the war depends on the Tomcat. So it's not self-contained. The second rule that is broken is that your application is not completely configured independently, that the application doesn't hold its own configuration, or the configuration is not made through environment variable. In general, let's say if you want to use a data source, you will use a Symbolink link in your app. And then on the application server side, you will configure the symbolic link to point to a real data source. But again, it's the application server that is the master of the configuration, and it defeats, again, another rule. As I mentioned already, the GVM has a lot of advantages when you are doing a long-running process. When you are doing a long-running process, the GVM is cool because it can adapt to the workloads, which basically is opposite to the fact that most languages, they compile statically to a native executable, and then they cannot adapt. However, this GVM trick first takes a lot of memory, okay, but also it takes a long time to start up, which is not what you want, again, because you might want to kill the pods, and then you need to start a new one very fast. Same things. In general, in legacy web application, you write to different files. And then you've got an issue when you are in the cloud because you need to scrape those files and to send them to your log aggregator. And yeah, so in general, what you would like is to actually directly write to the console, because all those cloud providers, they are able to stream the console and to send it wherever you want. So those are at least 4 factors that are broken by default. So if you just lift and shift, you won't be able to follow those rules, and probably it will be hell afterwards. And then you've got additional issues. If you have been doing any Java, know a bit about Java, you might know that there is this thing called reflection. And basically, reflection is the fact that at runtime, you will introspect your code and say, oh, I need, let's say I need this class, so I will load it from the class path, and then I will create a new object of this class. And then with this new object, I will do some setters and getters and manage the state. And since it's done at runtime and you do it a lot of times, it might impact your performance. Another performance hit is at startup again, so it will slow down your startup, is like those traditional frameworks such as Java EE or Spring. They try to read your class path to be smart to help you. So this, in general, this is done through annotation or checking for all implementation of an interface. This is done at startup time, and again, it slows down your stuff. So those are all the reasons why, when you want to move to the cloud, you are a GVM shop. Even if it's not Java, you are not super happy in general. So what can we do? Well, as I mentioned, we can rewrite the app. This is called the atomic option. And the problem with this approach is, and this cost has no business benefits. And if you work in normal companies, you will know that the business has the money. And if you tell them that you will be spending some millions without bringing them any benefit, then probably they will say no. The second is the delay, because when you decide to rewrite the app, and at the end of the rewrite, it might be 1 month, 2 months, 3 months, you don't know. Of course, there is always the risk that this rewrite introduces new bugs. And when I say there's a risk, there's probably 100% chance. And finally, it has a huge impact on the organization, because imagine you have been having a team of 10 developers that was able to do the new project and the maintenance of your app. Now, if you want to rewrite the app, you probably need like 20 developers. And how you will organize them? So how do you put the standards legacy developer on the new app, or do you keep them on the old app? And meanwhile, business will probably want to add new features. So this is an additional risk, additional delay, additional costs, and additional headache for the organizer of the team. So those two options, they both are bad. And I believe that there is a middle path. And the idea behind this middle path is not from... basically, imagine we could reuse the existing code, but change the way they are used. So we would keep the annotation from Spring, but we have a framework, a library, whatever, that is able to read those annotation and to understand that, hey, we are in the cloud, we should do things differently. And at this point, we can introduce something called GraalVM. And GraalVM, is the problem with GraalVM, it's a bag of different features. One of the features is that it's a standard GVM platform, so you can use GraalVM instead of the Oracle JDK or adopt OpenJDK. It also allows to have polyglot applications, so you can, for example, have your legacy application in Java and then introduce some R stuff, and it will be run by the same platform, so your performance might be a bit better. And there are a couple of languages already out of the box, but there is also a framework to create your own language, or let's say to move your own language to GraalVM. So for example, the Ruby implementation, I'm for sure, uses Truffle. It's called Truffle Ruby. And basically, it allows you to embed Ruby code in your Java app with seamless integration. One additional feature of Substrate VM, which is the one that is use GraalVM to take any bytecode and to create a native executable. And as I mentioned before, the GVM has two downsides in the clouds. The first, it's very memory hungry. And the second is it has slow startup time. And if you take this bytecode and you migrate it to a native executable, then you are on par with, like, I don't know, C or Go languages that basically do the same, create a native executable. This is done through a process called ahead of time compilation. And of course, it's not perfect, this process right now. It has a couple of limitations. So for example, if you use reflection, that means that at runtime, you will be able to determine which class to load, and you will be able to create these new objects, etc. But if you do ahead of time compilation, basically it will remove everything that it cannot follow the path to. And reflection, you cannot follow the path by default. So you will need additional configuration to say, hey, at runtime, this is necessary, so please don't remove it for my final native executable. Another issue with Substrate VM is it's not cross-platform. So basically, if you are running your application, sorry, if you are building your application on macOS, for example, and in the end you want to deploy it to a Docker, then you will need to have some kind of trick to have a small Docker file, just as this one. So here, for example, you can see that I'm using the entire build in Docker file. So here I'm creating the native image out of the jar. And finally, of course, I will run it. So this kind of stuff is necessary. And of course, if you are not very at ease with Dockerfile and with multi-stage Dockerfile, it's not that fun. It can be done, but it's additional effort. So this is the sum up. GVM write-runs run everywhere, but if you are in the cloud, you don't care that much anymore. Basically, your jar or your war is not the deliverable anymore. What the package is the Docker container, and basically it's already run everywhere. And you can adapt to the workloads. This is good for long-running processes. This is not so great for short-running processes that might happen in the cloud environments where basically your pods are killed every now and then and restarted from scratch. On the opposite side, it has a lot of memory consumption and it has longer startup time, whereas native executables, they have those benefits. So in the end, it looks like having native executable in the cloud environment, it's much better than the GVM. And through GraalVM, we can keep the whole development chain up until the end where we can do some ahead of time compilation. So as I mentioned, there are basically some frameworks that allow that, and they have two common approaches. Basically, in the end, those frameworks, they create code that is GraalVM friendly, where you don't need to configure that much reflection, or basically they use another reflection mechanism, or they provide you with the configuration for GraalVM native image. And also, for example, they do the reflection at build time. So instead of at runtime, letting you introspect an object, then they will generate this stuff at build time. So basically, we are shifting all the runtime performance hits at build time, which might be an issue if you want to have very fast feedback cycle. But as we will see, there is a way to combine best of both worlds. And here, those are those cloud native frameworks between quotes, because I don't know if they are really cloud native. That's how they advertise themselves. There is something called Micronodes, which is developed by a company called Object Computing. Quarkus is provided by Red Hat. Elidon is provided by Oracle. And there is an initiative by Spring Boot people to make it also cloud native, GraalVM friendly. Right now, it's still experimental, so it's between parentheses. I want to demo you something, and my use case is a URL shortener. So basically, the traditional approach of a URL is you have your space of all URLs in the world, and you have like this small URL, and you want to create a projection that goes from the long URL to the short one, and then the way to get back again. And it's quite CPU intensive because there is some mathematical function to apply to, and you must think about the right one. And also there is this problem of collisions handling. So I take another approach. Instead of having a mathematical dejection, I will just, when I'm submitted a long URL, create a random link. If it already exists, then I will generate a new one, and I will store those mappings. So basically, I'm training off CPU time versus storage space, which, yeah, it's my use case. I will use a legacy Java EE application. The only fantasy that I allow myself is I wrote it in Kotlin. It's using JAWS ERS. So basically, this is the API to do REST web services in Java. And I will store the mappings in Hazelcast IMDG. This is my initial state. So basically, you can see that everything runs in the GVM. I have a Tomcat application. Has some jars, for example, Catalina, Servlet, whatever. They are not the right name, but basically it's to make you understand. Catalina is just the inner working of Tomcat. The Servlet jar is what I'm supposed to use, as well as JAWS ERS. And then I have my war, which is composed of my controller class. And of course, inside I have a lib library, webinflip, in which I have a Hazelcast client.jar, which communicates with my Hazelcast IMDG, basically to store my mappings. And by using the framework, and as you can see from, well, as you will see from the code, it will be very, very similar. I will just switch the deployment completely. And now I still have the GVM in development, sorry. But now my jar is self-contained. Basically, I've completely removed. And Quarkus will be the one to allow me to use the servlet and JAWS ERS. And I will still be using the Quarkus Hazelcast clients. And as you can see, those will be just like classes. So they won't be regular jar artifacts. All classes will be at the same level, at the root level, inside my final jar. So this is development. And as I mentioned, GVM is not so great for cloud application. So the good thing is I will be using these deployments during development. But then at runtime, to deploy to production, I will create my native executable. And as you can see, it's pretty similar. But instead of having an application.jar that runs inside the GVM, I will just have a native executable that consists of the exact same port. So yes, I've talked. So now I can show you. And I have these other. So the POM is, let's say the POM is generated by Quarkus automatically. So if you know about the Spring Starter, here Quarkus has the same. So you can define what version of Java you want, if you can define your extension. So here, for example, I use Kotlin, and then it generates everything. The important stuff is I want to use JAWS ERS, so there is an extension for REST Easy, and I want to also use Kotlin, so there is an extension for Kotlin. And then we have our integration with Hazelcast, and also, yeah, it's the same. And then this is very, very easy. I have my controller. And as you can see, this is standard Kotlin code. here, more importantly, you see this is exactly the code that you would see in a traditional JOXRS Java E application. This is from. So we are reusing the same. Okay, and now, of course, it won't work because I don't have Hazelcast IMDG behind, but you will see it, you can run it on the GVM very easily, and it won't change your settings. So here, you can start it like that. And so at development now, you benefit from debugging, you benefit from being able to set breakpoints, to check the state of your application, whatever. Besides that, you can create Docker images that are like, that will run on the GVM, but that's not my point, because I want to run everything as a native executable. And those two files, again, are provided by Quarkus when you create your project. So there is this Docker file native. And if you run that, and I won't run it because the head of tab compilation takes a bit of time, you can see that basically you've got this specific stuff called URL shortener runner. And those runner basically is the basics in which it will create this native executable. And this native executable is not a macOS native executable. So Quarkus allows you to do without this like multi-stage Docker file. And if we can check this file, as you can see, it will be super huge. Right, so it's quite huge. But now, if we just check Docker images and grep URL, so this is the second step. The second step will, out of this file, create this URL shortener Docker image. Then we can see that it's not that big anymore. It's an acceptable size. And now, if I Docker compose up, just to check that it works. So my Docker compose is the following. I have my URL shortener, and I have a Hazelcast IMDG behind. And I forgot to do something. So I forgot, may I do like Control-Z, background? Yes, I can do that. And I need to find the command line because I forgot to use the command line. So and this gives me this new URL. So this is my short link. And now if I just take this short link and I want to find the complete link, the long link. Sorry. So I got the one back. So instead of computing every time, it just like goes toward Hazelcast IMDG and check. So my point in that talk is my advice is to advise you to walk the middle path when possible, because if you do lift and shift, probably you will have a lot. At worst, everything will break. If you rewrite everything, there is a lot of cost and risk and organization issues. So my advice is to reuse the existing codes and use frameworks that know how to use the previous codes. And then you will have the best ROI for the win. So thanks for listening to me. You can read my blog. You can follow me on Twitter. you can have a check at the Quarkus Hazelcast client, which is the official Quarkus client for Hazelcast. And if you are interested in the demo codes, then please have a look at this GitHub repo, which is publicly available. And now perhaps you have some questions.
Thank you, Nicolas. Like, how can we compile Java to native using GraalVM? And what are the advantages? Is it reduction in memory consumption or any other like startup performance, etc.?
So basically, when you are doing the ahead of time compilation through GraalVM, you are like taking your bytecode, which is supposed to run inside the GVM, and you make it a native executable. So the advantages, they are twofold, as I mentioned, because it's the GVM now doesn't need to start, it doesn't need to initialize, you have faster startup times. And the second is memory consumption is lower because there is some overhead of the GVM trying to like improve the bytecode every time. So for long-running processes, you will actually have lower performances, again, because the GVM is able to adapt the code to the workload. But for short-running processes, such as serverless, or if you are basically like regularly killing your pods because you are running a Kubernetes and you need to make some way, then actually it will be more performant because when you start a pod, it will start much, much faster.
Okay, thank you, Nicolas. So we'll wind up with the